this video, we'll find area using right endpoints, using left endpoints, and using midpoints. This is the 5.1 pre-class video. Alright, we're shifting gears quite a bit in this video because we will be talking about how to find areas. Now we've calculated areas before in like geometry class. We find the area of a circle, an ellipse, a rectangle, and a triangle. But we're going to look at trying to find the area between a function and the x-axis. For now, we're just going to approximate the area. And let's look at this problem statement. Find the area under the graph of f of x equals the square root of x from x equals 0 to x equals 3 using three rectangles and right endpoints. To be able to do this and to communicate this idea well, we need to introduce some new notation. So let a equal 0 be the start. So a is the start and b is the end. So b is equal to 3 because we're going from x equals 0 to 3. And let n be the number of rectangles. So in this case, we're trying to use three rectangles to approximate the area under the curve. And the length of the base of these rectangles we'll call delta x. The way to calculate that base is to do b minus a over n, right? 3 minus 0 over 3. That'd be a base of 1. And the last bit of notation we'll use is capital R with a subscript of n. Means we're using right endpoints using n rectangles. So in this case, we're trying to find r sub 3, right? Right endpoints using three rectangles. All right, let's get a visual now. So a is equal to 0, that's where we're starting at the origin, and we calculate delta x to be 1, so that's the base of the rectangle. So we're going from 0 to 1 with the base of a rectangle, and using right endpoints means we're going to use our right endpoint on this subinterval from 0 to 1. So the right endpoint is x equals to 1. We're going to use that right endpoint to determine what the height of our rectangle is. So here's our first rectangle. The height of the rectangle is determined by the function value at x equals 1. Well, that's just one rectangle. Let's look at our second rectangle. So delta x is equal to 1. So we're shifting over now on the subinterval from 1 to 2. And our height of the second rectangle is going to be determined by our right endpoint at x equals 2. Right? The height of the rectangle is the value of our function at x equals to 2. And likewise for our third rectangle, now we're looking at the subinterval from 2 to 3. And the height of our rectangle is determined by the value of the function at x equals 3. So notice that the top right corner of each one of these rectangles is touching the curve, the square root of x. Next, let's name these rectangles. So the first rectangle called A1, because we're going to calculate the area of it. So A1, second one A2, third one A3. Then our approximation to the area under the curve using right endpoints and three rectangles would be the sum of these three areas. And we know how to calculate areas of rectangles. That's height times base. So notice the height of each rectangle is a function evaluated at the right endpoint of its subinterval. So we have to evaluate our function at 1, 2, and 3 and multiply by our delta x, which in this case is just 1. And this turns out to be 4.146 rounded to 3 decimal places. So in conclusion, we approximated the area under this curve from 0 to 3 using three rectangles and right endpoints, and it turned out to be 4.146. All right, let's do this again, but this time let's approximate the area under the curve using left endpoints. So the notation is pretty much the same. The only thing that changes is instead of r sub n, we use l sub n, l for left endpoints. We have our three subintervals again, and now we're using the left endpoints of these subintervals to determine our height of the rectangles. So in the first one, well, the height of the rectangle is 0 because our function evaluated at 0 is 0. So the height is 0 for the first one. The second one, our height is determined by the function at x equals 1. And then the third one, the height of our rectangle is determined by the function at x equals 2. L3 is the sum of those areas. And again, we do height times base, add them all up. And in this case, we get that calculation, which turns out to be 2.414. All right, let's do this one more time and approximate the area under the curve from 0 to 3, but this time using midpoints. So again, notation is the same, except we do m sub n for midpoints, m for midpoints. We got our three subintervals again, but now we're using the midpoint on each subinterval to figure out what the height of our rectangles are. So there we go. There's the height of the first rectangle, determined by the function value at 0.5. Height of the second rectangle, determined by the function value at 1.5. And there's our third rectangle. The height is determined by the function evaluated at 2.5. So we name them again. M3 is the sum of those areas, which turns out to be our height times base again. We need to evaluate our function at those points and plug in delta x equal to 1. So M3 turns out to be 3.513 to 3 decimal places. Notice the difference between midpoint rule and the other two rules is that the rectangles are intersecting our curve at the top middle of the rectangles. Alright, that's it for this video. Hopefully you're all warmed up for the next class.